Welcome back to another one. What did the sushi say to the wasabi at the party? At the house party too. It was going off. Oof, 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 oof. Where's my soy mate? All right, here we go. Straight to it. We've got limiting sums. I kind of hinted that we would touch on this last video. Excuse me. So a limiting sum is something that is unique to a geometric progression. It will not happen with arithmetic. It only happens with geometric. And essentially, it means when our certain numbers hit a limit. Okay, so that means if I add all the numbers together and then I approach a certain limit, now it happens when the absolute value of your ratio is less than one. Fancy way to say when R is in between -1 and 1. So, for example, negative half, positive a third, any number that lives within that range will end up limiting our sum. And I'll show you what I mean. Okay, this is probably the easiest way to think about it. Let's say Mr. K takes a 1 meter step, and each step is half the distance of the previous. So let's just say my first step, I travel 1 meter. And I'll try and make this now 1, 2. You know what? Let's just say, pretend that that's 10 meters or 1 meter there. Now, the next time I take a step is going to be half that distance, which is going to be 0.5. And again, I'm just pretending 0.5. And then I take another half of that. That's half of that becomes 0.25. And then half of that becomes, what is it? 0.125. And then it gets even smaller and smaller. And then what you'll notice is it gets smaller and smaller and smaller. And then eventually, I kind of get closer and closer to 2 meters, pretending that I drew this nicely. But I'm actually never going to reach there because it's going to get closer and closer now. Hopefully that makes sense. You can see that my sum is limiting. It's getting smaller and smaller and smaller. It's kind of like an asymptote. We'll talk about that. Now, you've got a nice little formula for this. The limiting sum of a GP looks like this. Your SN, or sometimes we call it limiting sum, so it means it's an infinite sum. Okay, that's just some way to say that it's the sum of infinite terms. And sometimes we just label it as S, but it's just going to be A over 1 minus R, and we know that A stands for first term. And we know that R stands for your common ratio. Okay, that's what it may look like. Now, taking a look at this question here, keep it short and sweet. Find the limiting sum of this. So as we can see here, let's go, what's minus 6 on 18? Let's find the common ratio first. It's minus 6 on 18, which is also the same as 2 on minus 6. And we can see here that your common ratio is negative a third. Okay, both of those fractions are equivalent to negative a third. And so here, my S, or if you want to call it your limiting sum, is going to be given by A, which is your first term, over 1 minus R. And in this case, it's going to be 1 minus a third. So just be careful with your negatives. It's 1 take away R. And then you just put that in your calculator and you tell me what you get. 18 over 1 minus, let's try our best here. Negative 1 on 3, and that should get us 13.5. So that means the more terms I add, I get closer and closer to 13.5. Okay, now if you want to sit here and calculate that yourself and try it with 4 terms, 5 terms, 6 terms, 7 terms, what you'll notice is the closer we get using your SN formula, we'll get closer and closer to 13.5. Hopefully that helps, and I'll catch you guys in the next one. See you later. Bye.